In this short video, I will briefly explain the functionality of muons in solid-state systems. First of all, let me tell you what is muon and its basic properties. So, muon is a fundamental particle like electron and proton. It has a mass of 207 times the mass of the electron and 1/9 the mass of the proton. One can call it as a heavy electron as well. So it has magnetic moment 3 times the magnetic moments of protons. It has a charge value similar to the electron, but both positive and negative muons are possible. The lifetime of muon is very short. It is only about 2.2 microseconds. After 2.2 microsecond, muons decay into positrons. Another interesting facts of muon, it has 100% polarization even at ambient condition, which in the end help us to study the properties of matter. In condensed matter physics, we consider mostly the positive muons as we are interested in the properties of electrons. So positive muons inside the sample are located close to the electrons as we implant the muons into the sample. So the question is, the functionality of muons is actually similar to a secret agent. We know that what usually a secret agent does, Agent usually go to a place, spying that place, and collect information and leave the place without leaving any traces. Muons in principle also work like this. It enters into a material, try to sit in a lattice where the potential energy is minimum, and starts to interact with the surroundings, collect information and decays into positron detector. And that positron carries local information of the system. So this is the how it works in principle. So one implant the muon into a sample, and this is actually the larger in the enlarged version of the sample of the lattice. So in what usually happens, since muon has a large gyromagnetic ratio, it is very much sensitive with the local magnetic fields. It interacts nicely with the magnetic environment and decays just within 2 microseconds into positrons. Okay. So this is actually how it happens. So the muon decays into positron. So interaction of the muon spins with the magnetic environment, and there is an anisotropic decay, muon decay in the direction of the muon spin. And so this detection, this detection of the decay positron and the positron detector, and this is actually the positron is collected. So in general, muon is a wonderful technique to investigate the magnetic and superconducting properties of matter. And over the decades, it has been very successfully used to understand the local properties. In a sense, this is also very solid complementary technique to nuclear magnetic resonance. So what happens for example, in a magnetic materials, when the system is very homogeneous, then muons enter into the sample, implanted into the sample, and then muons start to process because of the interaction with the local surroundings. And then the muon spin polarization, if one plot as a function of time, this is shows the nice muon polarization. But when the muon has implanted in the relatively inhomogeneity sample, then the implanted muons essentially have different environment leading to different energies of precision. Accordingly, muon spin polarization as a function of time behaves differently. Yeah. So what happens actually as a function of time, muon spin polarization looks like this. In general, for a magnetic materials, three important informations one can immediately get from the muon experiments. And these are the following. First, the amplitude. This is actually gives you the information about the magnetic volume fraction. And then the frequency. This gives you the information of about the size of the magnetic moments, order parameter, and the damping. This is inhomogeneity within the magnetic areas. Yeah. So in principle, muon is a wonderful technique to get the information about the local information about magnetic materials. There are many places now muon one can perform muon experiments, in particular for condensed matter physics. So these are the TAMP, for example, in Canada. Then ICES, it is located in United Kingdom, and then PSI Switzerland, and then also KEK in Japan. So thank you very much for watching. If you like, stay tuned.